Alrighty, welcome friends. We are on 4.2 and I blabbed out a bunch for you because we are not doing intercept form and that was all a bunch of stuff that doesn't apply to us. So we're going to just get right to it. We already talked about standard form equations of parabolas, which are quadratics. We had ax squared plus bx plus c. Sometimes these were minus. And that is going to be one of the ways that we see parabolas probably more often than vertex form, but occasionally you're going to see something in vertex form, and it's called vertex form because you can find the vertex just by eyeballing the equation. The a value, as it says down here, still tells you the same information. A positive a still means it opens up. A negative a still means it will open down. An a value less than 1, like a fraction, is still going to make it kind of wide, whereas an a value greater than 1, like 2, 3, 4, is going to make it taller and skinnier. So it's going to make it steeper as that value increases. So that's all still true. So here's what we want to kind of take a look at. How do you look at these parts of your vertex form and know that you have the vertex just by looking at the equation? This is going to move your original parabola around. Our parent graph looks like this, and the vertex is at 0, 0. But the values in this equation move it. The h value moves it to the left and right. But because it's enclosed in the parentheses and it's moving it, it actually moves it in the opposite direction that you think. So we would have a positive h will actually move it to the left. And if you did the 2, 7 work, then you know that this happened with the absolute value graphs as well. A negative h will actually move it to the right. And just like the absolute values in 2, 7, a positive k will actually move the whole thing up, and a negative k will actually move the whole thing down. So in doing that, to find the vertex, moving it left and right, you would have to use the opposite of the h value and then use the k value as is. And that's actually identical to what you did in the 2, 7 video with the absolute values. It's just that when you graphed those absolute value graphs, once you located the vertex, you did straight lines on either side. So the process is very similar, or should be if you did that assignment. And what we have to do now is locate some points on each side. We'll still use the axis of symmetry as x equals the x coordinate of our vertex, which would be that opposite of h. And so that's still going to be just an eyeball activity as well. So here you don't get a lot of math. The only thing that you need math for in terms of our list of items is going to be to find that x-intercept. You can't just use the c value anymore because there isn't one. So you have to actually go back and plug in x equals 0 to the equation to find out what that would be. And we'll do that here with these examples. So let's look at some number examples to make it a little easier. Here I have an a value of 1/4 that's positive and less than 1. So I'm kind of thinking that's going to open up and be a little wider than normal. So if my graph doesn't look like that in the end, I have to rethink it. Looking here, I'm going to identify the vertex to be the opposite of h and then k. So negative 1, 2, 3, up 1 is going to be my vertex. That makes it easy to find my axis of symmetry or line of symmetry because I'm going to need a vertical line that comes right down through that vertex, which means that it's going to have to be located at the same x position. So writing it as a vertical line equation, it's going to come in at x equals -3. Okay, then if I do this up here and I plug in a 0, I'm going to go ahead and put in a 0, and you guys have your calculators, so I would encourage you to use that. But otherwise, you have to go through PEMDAS. You're going to end up with 9/4 plus 1. You end up with 3 1/4. All right, so that means that at 0, I'm at 1, 2, 3 1/4. And then what I like to do is utilize the fact that the line of symmetry is a line of symmetry. And if I'm at that height and 1, 2, 3 to the right, then 1, 2, 3 to the left, I'd be at that same height. So I'm starting to get some points that I can use in my parabola. And then you can kind of plug in whatever number you want. So let's say we tried plugging in a 1. So I would have 1/4 out in front of 1 plus 3 squared plus 1. That's going to be 4 squared, 16 over 4 squared. So I end up with a 5. So if at 1 I'm at 1, 2, 3, 4, 5, and that is 1, 2, 3, 4 to the right of my axis of symmetry, then 1, 2, 3, 4 to the left, I'd get another point. So then I can kind of draw my parabola in based on what I'm seeing. And it is a little wider than the normal one, and it's opening up, so I can feel kind of good about that. How about this one? What do I know about it based on my A value? Well, I know that it's going to open down and probably be skinny because 3 is greater than 1 and it is a negative value. So the first thing I want to find is my vertex because that's easy peasy. I use my eyes and I look here and I say I'm going to use the opposite of H, which is the thing inside the parentheses, and then I'm going to use the K value as is. So at 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, I put my big old vertex. Immediately, I know my line of symmetry or axis of symmetry is going to be x equals 2 because I simply use that 2 from the vertex, knowing that my vertical line has to come down through there. I guess we could try the y-intercept again. So I'm going to plug in a 0. And then I'm going to be looking at 2 squared. So that's 4 times negative 3 is negative 12 plus 8. It's going to kick out a negative 4, it looks like. So at 0, I'm at negative 1, 2, 3, 4, which is 2 on the left side of my symmetry line. So then 2 on the right side would be another 1. This thing is very skinny, and so if I go further, I'm probably going to end up with points that are way off of there. So I'm going to go ahead and connect what I've got up through the vertex, coming back down. And again, I ended up with something that makes me feel like I did it right. Oops, I didn't mean to erase that whole thing. It makes me feel like I did it right because kind of thinking about it ahead of time based solely on that A value, it looks like it should have been upside down and skinny. Alrighty. We are going to kind of do applications on a separate day, but since we just have this one example, I'm going to go ahead and do it now. We are not doing intercept form this year, so that's why I broke out that big black blobby pen. And so from this point on in your notes, you can just kind of ignore these. We're not going to do the rest of that notes page. You are responsible kind of for up to this point. All right, so let's take a look at what this application looks like. The Tacoma Narrows Bridge in Washington has 2 supported towers, each rise 307 feet. So you see that in the markings above the roadway and are connected by suspension cables as shown. Each cable length can be modeled by the function given where x and c of x are measured in feet. So what are we getting at here? The x is how far out you are in this bridge, and then the y is going to be how tall the wire is at that spot, if that makes any sense. So if you go out to a certain spot, what is the height of the cable, this measurement here at any given spot? So here's our equation. They gave it to us. So keep in mind, this is in vertex form. So the easiest thing for me to find is the vertex. I take the opposite of the H, and then I have the K value as is. So that means that my vertex is at 1427. So looking at this, this is going to mean that out 14 and 100 and then up 27 is the vertex of this. So that's telling me that 1400 is halfway across the bridge and 27 is the height at that spot. So whenever you have word problems, they're going to be asking you about the things that we know how to find. So when it talks about the shortest cable, the height of the shortest cable, that has to be part of something we know how to find, like the vertex. So since 1400 was the location of how far out it was, then 27 feet, is this feet? Yes. 27 feet is the height of that shortest cable because it's really just the Y value at that spot. All right, then this one's asking me for the distance between the 2 towers. So be careful about that. If 1400 measured to the middle, then obviously you'd have to go another 1400 to get to the other side. So you have to use a little bit of logic and a tiny bit of arithmetic to find out that that must be 2800 feet from one side to the other. So this setup, whenever you have a vertex form equation, it's pretty easy to get the information if they are asking for the pieces of like the vertex. Wow, I can't talk. So if they're asking for any pieces of the vertex, you're going to use that format. Alrighty, so that is that, and you should be able to be successful on 4.2, and then there will be a separate videos to give you more guidance on how to do the application problems. Have a great day. Bye.